Hello and welcome to the WGG How-To video for Is All Slime Created Equal? This activity will highlight the STEM career of chemical engineering. Chemical engineers apply the principles of chemistry, biology, physics, and math to solve problems that involve the production or use of chemicals, fuel, drugs, food, and many other products we use in our day-to-day life. As learners take on the role of a chemical engineer, they will do something different than other WGG activities. Instead of designing or building a product, learners will design a test for a chemical product called Slimy. Specifically, they will take on the role of a quality control expert. This is an example of a position that a chemical engineer might pursue. The STEM big idea for this activity is chemical reaction. Here are a few quick notes to help you support learners throughout this activity. First, let's start with the idea of a polymer. A polymer is a substance that has a molecular structure that is repeated, as you can see here in this image. Glue contains an ingredient, which is a liquid polymer. That is, it has a repeated molecular structure. When borax combines with the Elmer's glue, it links these liquid polymers together to create a large, flexible polymer, which we call slime, or in this case, slimy, the playful polymer. It is the interaction, combination, or chemical reaction of borax and glue that yields slime. The materials needed in this activity include water, string, borax, a mixing bowl, measuring cups, Elmer's white glue, sandwich bags, a ruler, plastic spoons, food coloring, and water. Before the kids walk in, you want to make sure that you have familiarized yourself with the design challenge. You have all your materials that you need ready to go. You've read the facilitator guide as it contains many important details for this activity, and you've set the activity up so that when the learners come in, they can begin to have fun. To get kids excited about this activity, simply let them know that they will be making slime. What learner, young and young at heart, doesn't want to get their hands dirty in the gooey, stretchy, sometimes yucky, but fun substance, or shall I say polymer, that is slime? Now, let's check out some highlights for this activity. As with all WGG activities, when learners log into the WGG environment, they are presented with an overview or list of steps for this activity. The first step will introduce the design challenge, set the context, and preview the engineering that is to come. Learners will also be presented with the design criteria for the activity. Remember, in this activity, learners are quality control experts, and they are testing the slime that they make. They will create tests to determine the bounciness, the stickiness, and the stretchiness of slime. Now let's go over how to create this flexible polymer we call slime. To start, you will combine 1/2 cup of glue with 1/2 cup of water. Use a few drops of food coloring to change the color of your slime. In another bowl, mix 1 teaspoon of borax with 1 cup of water until the borax is dissolved completely. You will then add the glue mixture to the borax solution, stirring slowly. Use your hand to get the real slimy experience. The slime will begin to form immediately, so dig in with your hands. Yes, get a little messy, and knead it until it gets less sticky. Pour the excess water out, and voila, you have slime. In this activity, learners will design tests for the slime for stretchiness, bounciness, and stickiness. Here's an example of a test a learner might conduct to determine the stretchiness of slime. One might hold the slime up and let gravity pull the slime down, measuring how far the slime stretches. This is just one example. You might also imagine two students pulling the slime horizontally apart and seeing how far it stretches. As always, encourage students to create as many different types of tests as they can, just making sure that they create tests that help determine the bounciness, stickiness, and stretchiness of the slime. Afterward, place the slime in a Ziploc bag so learners can take home and show off what they created. And yes, that slime is the chemical reaction of an ingredient or a polymer in Elmer's glue with the borax that links that polymer into many polymers to create a long and flexible substance we call slime. Finally, we have a few facilitator tips where the gotchas can get you. So for extra considerations, remember, use Elmer's white glue, not Elmer's school glue. This will make the difference between a liquidy slime and the slime we all know and love. Be careful, slime will stain and stick to porous surfaces, so this includes paper, fabric, clothes. Use safety glasses. So even though this is a fun activity, learners are still working with chemicals. This is a recipe for slime. So careful measurement guarantees success. Fun, slimy, messy joy.